Hi, so some more modulus equations. Let's see what happens when we go and try and solve this equation over here. 2x minus 3, the modulus of that value is equal to 2 minus x. Now, if I go and take the algebraic approach of squaring both sides, I'm going to get 2x minus 3 all squared is equal to 2 minus x. That's going to give me 4x squared minus 12x plus 9 minus 2 plus x equals 0. And that's going to tidy itself up to 4x squared minus 11x plus 7 equals 0. And that will factorize quite nicely, thank you, as being 4x and x, 7 and 1 minus minus. And so I'm going to get that x is equal to 7 over 4, or x is equal to 1. Now, are those answers valid? Do they work? Let's take a look at a little diagram and see if it makes sense. Right, so here are a set of axes. Where are your axes? There we go. Draw those. To begin with, I've got the line 2 minus x. So it's got a negative gradient. It's going to go through 2 on the y-axis. And let's get the line drawn then. So it's going to go through there. So it'll be a line that goes something like that. There's my line, y is equal to 2 minus x. Then I've got the modulus graph. The modulus graph is 2x minus 3. The critical value is going to be the value that makes that bracket 0. The value that will make that bracket 0 will be 1.5. So in other words, it's somewhere over here. The gradient is 2. So I'm going to go across 1 and up 2, across 1 and up 2. And I'm just going to match those. The whole thing is symmetrical. And so here I've got my modulus graph. Got one part that goes like that. And the second part that goes like that. And we can see quite clearly that the two graphs do cross. The first point of intersection is over here, and that occurs when x is equal to 1. The second point is over here, and that occurs when x is bigger than 1.5 but less than 2. It's actually going to occur when x is equal to 7 over 4, 1 3/4. So yes, those answers are valid, and my diagram agrees with that. If we made the equation slightly different, if we went and looked at something like this, the modulus of 2x minus 3 is equal to x minus 2. This is where having just a little rough sketch is actually not a bad idea. So I'm not going to worry too much about my diagram being too accurate. X minus 2 is a line that's going to go something like that, isn't it? It's going to cross over here at minus 2, and it's going to cross over there at 2. And what does my modulus graph look like? My modulus graph bounces at 1.5, and it's got a gradient of 2, so it's steeper than my previous one. It's going something like that. And from this diagram, I can see that those two graphs aren't going to intersect. They aren't going to cross. My extraneous values are going to kick into play here. So let's just think about what's happening with this graph. Why are we not getting those solutions? Well, we need to be concerned about what's happening on either side of 1.5. So what happens when x is greater than or equal to 3/2? That modulus graph is going to be positive. So I can simply say it's going to be 2x minus 3 is equal to x minus 2. Simple linear equation, x is going to equal 1. Now here's the problem. I'm saying x must be bigger than 1.5, but I'm coming up with an answer that's smaller than 1.5. So nah, it's not going to work. Look at what happens when x is less than 3/2. Well, then the modulus bracket has to be made negative. So I put a negative in front of the 2x minus 3. I don't do anything on the right-hand side because there's no modulus sign there. So what have I got now? I've got minus 2x minus 3 is equal to x minus 2. Click my x's on the right-hand side. I'm going to get 3x is equal to minus 1. Actually, that's a plus, isn't it? So that's not minus 1. That's going to be 5, I think. Yep. And so x is going to be 5/3. 5/3, that's 1 2/3. So I'm saying when x is less than 1.5, I'm coming up with an answer that's bigger than 1.5 because 2/3 is bigger than 1/2. So again, no solution. So you've got to be careful. Sometimes you may end up with answers that are not correct, or that don't work rather than not correct. This is all logical following through, but we've just got to take into consideration the domains that we're working with. One more problem that we're going to look at in the next video. So if this all makes sense to you, move on to that one. See you next time. Goodbye.